And today's talk is going to be from somebody who should need no introduction in case you ever kicked them off your campus for being a nuisance. Nick Buraglio from ESnet is going to be talking about automation, orchestration, SDN, and technical debt. And he did want me to say that this is a talk that he gave at TNC, so if you happen to witness that live, this may be a little bit of a repeat, but I think the topics are important and should be valuable for people who are listening. So take it away, Nick.
So, hey, now for the record, I've never been kicked off campus where a skateboard was not involved. So, little minor correction there. So I also, this is derived from that. I actually took it and spent some time tailoring it a little more away from the SDN focused talk that it was, because I think it's important to sort of be a little more inclusive, and that's why, it sort of touches on automation and orchestration, because I think that's a little more relatable. But it is, a lot of the lessons learned were directly from doing sort of disruptive technologies, and specifically SDN, but it also, I've seen it in some other automation and orchestration efforts as well. So to get that started, I want to define a couple of things. Technical debt, we throw that word around a lot, but honestly, the first couple times I heard it, I had to go look up to see exactly what it meant in reference to, in reference to the way it was being used. So basically, if you look at Wikipedia, it's a concept in software development. I think that, realistically speaking, it's a concept in all information technology that basically reflects the implied cost of additional rework caused by choosing a easier or much more limited solution and having something done now rather than taking a little bit of time to figure out the details and do it in a way that it, likely won't need to be redone to address those errors. I like to think about it as, kind of the way I was taught to do certain things is basically measure twice and cut once. And any network that's been around, or any IT shop that's really, I think any IT shop ever, it has some of this, right? Everybody has it. It's not this thing that you get by not doing a good job. It's just an artifact of running production environments, right? You're going to have to make some concessions every once in a while. And basically, how do we deal with those, and how do they relate to changing things in major ways? In addition to that, this is how ESnet has been defining orchestration and automation. We've kind of broken it up. Orchestration we've defined as the automated management, coordination, management of our computer systems, the middleware pieces, and our services and elements within the network. Basically, almost a direct copy of the way you would find it defined in Wikipedia. That's sort of the way we're thinking about it. But we're thinking more about things as opposed to using the term automation as workflow management and automated service provisioning. So basically, automation, as I would define it, is I take a task that I repeat all the time, I write some code so that I no longer have to repeat doing the steps, right? I do one step, and those things are just abstracted away by the one step. Workflow management is a little bit harder, right? It basically is a repeatable pattern of steps that interacts with our operations support system, and that support system may be a bunch of different things. And it's tied directly to automated service provisioning, right? Because a lot of us that run networks, we think about how do I perform action X, Y, and Z, and to have the service available that provides A, I need to perform B, C, and D to do that, right? So basically programmatically chaining together configurations across different platforms such as your network elements, your compute nodes, maybe an IPAM, and whatever else. So that's the way we're thinking about how to deploy these types of services within ESnet. And just for a little bit more context, none of this stuff is really new, right? I've been doing networking stuff since the mid-90s, and back when I got started, it was writing shell scripts and using Perl to do things. We didn't call it automation. We basically just called it sysadmin scripting or just scripting. And a lot of us have been doing that stuff forever, right? And this isn't conceptually that different from the way it was done in the old days. Basically going in, provisioning like a DSL router for an ISP. You run some Perl that pulls some IP addressing that's not used out of a source of truth. It talks to the router, it SSH telnets in, back then it was telnet, and run some commands, basically screen scraping. That's been around for a long time. We're all pretty familiar with that. This isn't that different. CF Engine has been around since the early 90s as a systems management tool. When Rancid was released in 1990 whatever, a lot of us started using the login scripts as a smarter way to get into network equipment and perform tasks. And I'm sure that a handful of people on this list have done those types of things, right? Because it makes our lives easier, right? None of this is really new, I guess, is what I'm getting at. And so, why are we having such a hard time in some places and in some instances of taking the things that we're kind of already doing in our own way and then applying a little more structure to them? And I think the biggest reason for that is probably technical debt. But also, there's a handful of other things, right? We have a common reality. Like a lot of the things that you see, from the people that write blogs and the people that do podcasts and from the marketing machine that is out there saying no one's going to need a network engineer. You're all going to be programmers, blah, blah, blah. It's all, hyped up, right? But most of that's focused around a couple of things, and we can all relate to this on this channel, right? 99% of us are not hyperscalers. I would say probably 100% of us are not hyperscalers, right? We're not the Googles, the Amazons, and the Facebooks, and we never will be, right? So we don't have an army of 100 programmers to do these types of things. And in addition to that, developers who know networking really well are very rare. And network engineers who write production code, and I'm not talking about just scripting, like most of us can do that, but like a real developer that can write production code that's also a network engineer, also a bit of a unicorn. They're hard to find, right? And probably the most common one is time is a scarce resource. We have too many things to do and not enough time to do them. And because of that, many of us take on the mentality of it isn't broken, so I'm not going to spend time on it because the wheels need to be on the bus. And it's not broken probably often should be followed up with, but it's not efficient. And that's what a lot of the efficiency gain, a lot of the gains you get from automation and orchestration are, in fact, efficiency over time. I really like this picture of this guy with the free shrugs. I use it all the time in lots of different slide decks. I don't know why I like it. I just find it funny. But really, what it comes down to is the technology to do all these things is pretty unimportant. If you think back to the list I gave, we have Rancid login scripts, we have Perl, now there's Python. There's a million different tools you can use to do these things. But as technical people, sometimes we get in our own way by trying to figure out the how in detail rather than thinking about the what and the why. And that's where the difficulty often starts, right? It's a mental and a cultural adjustment to think about not the tool I'm going to use, right? What is the goal I want to accomplish is what we really should be thinking about, not do I use Ansible or do I use NSO from TailF or do I use Salt with Napalm? It doesn't matter. That's a very unimportant question to ask at the point of time when you're beginning down the road of automating things. Try them all. Start with the one that your systems guys are already using because they're definitely already using something, and work out from there. Make sure it's supportable. The technology is irrelevant, right? The outcome is the important part. So don't hyper-focus on the details. And because of that, sometimes that's a mental and a cultural adjustment, because many of us are highly technical people and we want to think about the details. And changing that brings on a lot of baggage, right? Because you'll have differing opinions, and this will stifle the ability to make decisions. And then socialize it, right? Social and cultural change is complicated. It's really messy. I'm sure all of us on this list can think about places that we've been, and jobs that we've had where, the people didn't agree on the mechanism of executing a certain thing. And so you had 6 months of meetings to hash those details out, when really it was a fairly unimportant detail. And it does take time. Thinking about how things are put together is a key part of what we do. Integrating into an existing ecosystem is intricate and difficult, and you have to think about certain little bits, but it's definitely doable. If you think about your particular network, most production deployments have, little or poor integration between the processes and the procedures. And a big part of the process part is understanding the thing that most of us on this call probably hate, which is the business logic, right? It's who and where and who pays for it and how it's provisioned. Once you figure out the business logic pieces, everything else really starts to fall in place. But I would guess that most of us don't think about those things, and we may not even have access to them, and they might not be written down. In addition to that, a lot of our stuff is hand curated. All the networks I've worked on in my entire career had elements of what we call snowflake, right? This is a one-off, and I suspect every network I will ever touch ever will have this as well, and that's okay. You're always going to have the hand curated. What you want to avoid is everything being, artisanally provisioned across your entire backbone or your entire ecosystem, by hand, by a person. You want to minimize that as much as possible. And the reason that a lot of them are like that is because, as an R&E institution, you've probably been around a long time, and a lot of what's there is just the result of organic growth over a long period of time, and maybe also subject to turnover, right? I don't remember why Nick did this at his last job because he didn't write it down, right? I'm sure that a handful of people that are from UIC on this list probably have said that before. But none of these are really technical problems, right? They're cultural, right? And that's one of the things that's messy about this, and that's cultural issues are one of the biggest contributors to technical debt. Ironic as that may sound, it's definitely true. And technical debt is the hidden limiting factor to any of these progressions. Now, when we did the last SDN network, and I realize SDN is it's a radical change when you're talking about, centrally controlling a whole bunch of network equipment, and when abstracting away the control plane, and when the control plane, if it goes away, then you're, learning MAC addresses and things stop, right? So it's very radical. But one of the things we learned the last time we did that at SC18, we provisioned arguably the fastest public OpenFlow network that's ever been available for use publicly. A couple of things popped up, and they're really, really obvious really quickly, is that integrating with existing systems was the hardest part. The technology was really quite straightforward, but when you take a new technology that's a bit of an island, because it's managed differently than everything else, and you plop it in the middle of something that's been in existence for a very long time, you have to figure out how to tie them together, or else you have this odd pocket of things you can't manage or that are managed differently, and that makes it a very large one-off, right? So when you integrate that with the existing systems, that starts to smooth over and minimize. And we discovered very quickly that in doing this, integrating with the back-end systems in particular were the hardest piece. Now in supercomputing, there's a database back-end that has been around for a long time, and it's what would be considered the source of truth for most of the things, 99% of the technical things that get provisioned at that conference. We had to tie into that, and we had to write middleware to make it fit, to make our ecosystem fit with that. That was difficult. That took probably, 2 weeks to make work, and of dedicated time, not just, an hour here and an hour there. It was a fair amount of reverse engineering and coding, and because it was historical, right? We had to reverse engineer it. We had to pull out the code and look at what it's doing. That became a big bit of technical debt we had to dig out of because it wasn't well documented. In other networks, so we were lucky in that case, right? There was a source of truth, and so we had this thing, this Rosetta Stone of information that had IP addressing and VLANs and patching info and port information and user information. It had billing information. It had everything in it. And almost nobody has that. That's rare. Lack of a source of truth for your network information is a huge hole of technical debt. And if you don't have that, you might get stuck on, we have to have that first. And while that is a noble goal, you probably won't. If you don't have it now, it's going to take you years to build it. And at that point, the hole that you're in, the technical debt, is already going to be so deep that you may never totally dig out of it in your career lifetime. So don't let the lack of the source of truth limit what you're doing. Understand that it's a limiting factor, but maybe work on it in parallel. And again, I touched on the business logic surrounding the technical processes. Understanding that is pretty important. That's also very difficult to do and shouldn't be a limiting factor in getting started. And I'm going to go into a little bit more about getting started here in a minute. Another piece of technical debt that we've all experienced is the technical sprawl and lack of consistent workflow. If you don't have documentation for the daily tasks that you're doing, and you have more than maybe 3 engineers that are doing things, they're not doing them the same way. That is almost a guarantee. Someone's going to have a naming convention that's different than somebody else's. They're going to do things in different orders. They're going to just have small, minor, subtle differences between between how they perform the same tasks. This is something that you can start to work away from, and it's one of the main drivers for doing automation and consistent orchestration of your services and your service workflow. And another big piece of technical debt is technical bias. We only do it this way because it's the way we've always done it, or we only use this equipment. We only buy things from this vendor. That's a technical bias, and it's going to limit you in the long run of how you perform your duties, how you build your networks, how you form your architectures, and how you end up running them eventually. It can provide dramatically skewed needs and requirements because you may box yourself out of something that may be easier in the long run, but might be a little bit harder up front. And again, this all goes back to what resources are available and the true definition of technical debt. So how do we work around all this? This is hard. This all sounds daunting. The best way, and this is how I got started, and I am not a developer. I can write poor Perl, crummy shell code. I can pick apart existing things if they're not too complicated and maybe make some minor changes, but I am by no means a software engineer. What I did was I picked a handful of things to push out in my lab and tried them out. I picked Salt, Napalm, Ansible, and I had already done a fair amount of work with CF Engine. So I started just playing around with them. I picked one little thing because I knew it wasn't an insurmountable thing I needed to get around. I needed to understand how this worked. And so I picked something that I'm going to do on every every network element. And I tried to automate that using the different tools that I had. I didn't try to boil the ocean. I didn't try to do anything overly complicated. I picked the hello world of automation and I tried to do it in a couple of different platforms. And I ended up landing on the one that was the most flexible and the easiest to, for me to understand and the easiest to implement. And again, I started small. I picked out what my needs and requirements were. Like I wanted to add usernames. I wanted to add a couple of environmental variables to a couple of different pieces of equipment that were multi-vendor. So I had to not only figure out how to do those things, but how to do them on different platforms. And that was by design. So I had properly scoped it very small. And I did a bunch of the detail work up front because I knew it would make less work later, but it did take significantly longer up front to sort of break that barrier. But once I did that, it made everything easier, and I just jumped in from that point. And I just got started. I discovered the problems I wanted to solve, and I set out to solve them, and I kept them really simple. You know, a lot of times when we think about things like automation and orchestration and whatever, SDN, you know, we don't necessarily, the buzzwords are out there, right? And so we think, well, I should look at some of that stuff. But like, think about what you want to solve. Like I had some very specific things that I wanted to solve, and I think these are useful. And I think most people, when they're thinking about automation and orchestration, this is really at the forefront of their mind, right? They want to minimize, or if they're really ambitious, eliminate completely repetitive tasks. I don't ever want to have to type, you know, IP NTP server, whatever the command is on, you know, to set an NTP server on a Cisco box more than one time. I want to run a script that just does it. And in doing that, it will allow me to free up time that I would have been manually typing things repetitively over and over a, you know, however many devices. And it will also minimize the likelihood that I'm going to mistype something, which I'm sort of infamous for doing personally. You know, remove the error-prone tasks. I'll type it once into the automation platform. I'll run it in the lab, make sure it works right, and then commit it, and it's finished. And so the likelihood of it being error-prone is very small at that point. And then I can hand it to somebody else, and I don't have to do it. You know, it can be any of the engineers can do something. They can push out the usernames or whatever based on the Ansible that I wrote. I ended up landing on Ansible as the platform that I chose. And that's ESnet's doing a fair amount with Ansible right now. We're also looking at a couple other platforms for specifically for networking, like NSO. But that's that's the path that I went down, and I think that it works, and it's a good start. So I would encourage everyone to take what I did and maybe make it better. And doing that, you'll get some byproducts, right? It's a bonus. It's a value add. You'll get reduced human complexity from configuration process, because we all typo things every once in a while. I used to always say, you don't get your senior network engineer card until you leak the global table to your upstream, right? And it was kind of a joke because most of us have done that. I've done it. Early in my career, I did it more than once. And it's one of those things that just happens. But if I could get away from doing that by taking myself out of the equation, then great. Maybe that isn't the way you get your senior network engineer card anymore. And also, we'll start getting folks thinking down the path of implementing a source of truth if they don't have one, or if they do have one, it will make it really clear right away that this doesn't exist in my source of truth, right? And maybe I can get this information over here, right? Maybe your technical database backend only has routing equipment and interfaces in it. It doesn't have IP addresses, but you happen to have an IPAM with an API, right? You can tie those things together. It doesn't always have to be this monolithic thing. It can be, the source of truth can just be here is a a set of things that have the information that I want, and I get to them in different ways, but I know where it all is. And if you do it in a way, that is taking what you already have in your existing workflows by starting small, by saying, I'm going to take these 3 tasks, right, and I'm going to automate them, then a byproduct of that is that it will integrate a lot more seamlessly with your traditional network that's already there, right? And this is, I think, is one of the things that makes SDN hard, because it's so different that it doesn't necessarily integrate with, let's say, a traditional routing or switched network, because it's not. It's an abstracted control plane. It's whatever product that the vendor has that is proprietary, and it's an enclave at that point. It's an enclosed black box. It's hard to integrate those with existing workflows. But if you choose something like this and start going down that path, it makes it a lot more palatable, and it makes it easier to integrate at your own pace. Especially if you don't obsess about the technology, right? If you think about the first 3 points, I want to reduce human complexity and implement the source of truth and have it integrate with my existing network, that will inform that decision, right? Don't spend a million years figuring out like, oh, I'm going to use this tool, right? I know I have a toolbox. I'm going to try a bunch of different tools. I'll use the one that works the best. That's a good way to avoid that pitfall of having to figure out that particular detail. And start at the top, right? Think about where the data is. Think about what you currently have. Think about, what do I have for an IPAM? Do I not have an IPAM? Do I have is it a spreadsheet, right? Can I export that to CSV and then programmatically pull out of it? Do I have a contact database? Does my security team have a systems database that they have a catalog of every system on the network, or a majority of them? Can I leverage that? Do I currently do running configurations and backups? Am I using Rancid or Oxidized or Unimus or SolarWinds or whatever? Can I look at what's already there, and then can I make a consistent template out of what I already have and push that out? There's lots of ways that you can get started, and I think that most of us probably have, I would say, a minimum of one of these things. Some of us may have all of them. But leverage what's already there. Don't try to recreate the wheel, because it will only make this less fun and much harder, and it will probably add to your technical debt that you already have. The idea is that it simplifies your life over time. It's a little work up front to create time. It's a DeLorean with a flux capacitor if you do it right. So break down those things, figure out where they are. This is just an example that I came up with. What's in my things, right? Where do I keep my backups and stuff? Because I went through this process, right? I never want to recreate a wheel if I don't have to. Mostly because I'm not a developer and I can't. So I have to work with the tools that are available to me. So I think a lot of this is pretty self-evident, really. It's real, this talk, I think, is more to encourage folks to say, yeah, we want to go down this path. Or if you've started down the path and you're frustrated by, the amount of work it's taking, or the lack of dividends it's paying out, it's to encourage you to keep going and maybe reduce your scope a little bit. You don't need to boil the ocean. You can boil a pot of water, you can make hard-boiled eggs. It's easy. But you have to start small. Successful deployments are, well, first of all, they're defined by what you define success as. They're very doable. If you define your successful deployment as, I am able to push out SSH keys to all of my Juniper equipment programmatically and use promise theory to make sure that it's pushed out every day and they're always consistent and they don't get changed. And if they do get changed, they get changed back. Then great. That's success in my book. If you can integrate it with your existing systems, that's a huge part of the process. But cultural changes and mindset changes and shifts, they take time, and some people need to go slow and understand that these little changes are actually beneficial, and they will free up time to do other things if they're just given the chance. And so, I always encourage folks to socialize these things and say, let them know, here's where we're at right now. What input's available? Can you help me with this? Do you know how to do that? What do you suggest we work on next? Socializing those things makes the cultural shift a lot less painful, if it is painful in the first place. Some places it is, and some places it's not. But realistically, the tech is easy. It's not. If I can figure it out, anyone can figure it out. And I've been going to town on this stuff for a little while now. So I think that, it's very doable and it's very straightforward. And much of it is really well documented, especially now, unlike maybe a decade ago, when it was sort of in its infancy and you didn't have that deep install base of folks that are doing it. You didn't have the communities around. You didn't have commercial providers that would actually come in and show you how to automate it and do some of it for you. Like, there's lots of opportunity nowadays for this kind of thing, and it will help you dig out of any technical debt that you may have, almost certainly. So those are my conclusions from the amount of time that I've spent doing these things. And I'm definitely open to any suggestions to the things that I'm doing as far as this in this space as well. So I've got some links to some things here. We talked about SDN a little bit, and this is basically, I forgot to edit this slide to just have my email on it. So if you want to look at the faucet configs where we did OpenFlow at SD18, they're on GitHub, and you can look at our production SDN graphs in the Champaign office where I am, or you can contact me if you want to chat about this kind of thing. I'm always up for that.
All right. Well, thank you, Nick, for that. Anybody who does have a question, if you want to either type it into the chat room, or if you're in a quiet area and just want to ask it verbally, certainly go ahead and do so. I wrote down just a couple of starter questions here. I think everybody likes war stories. Why don't you think back into your long history and maybe relive one or two events where a choice was made with technology and it was implemented, but it didn't really meet the needs, and then it needed to be reversed. Do you have any sorts of examples of that from your history of operation?
Are you asking me in particular?
Yep, you in particular.
Yeah, so I can talk about when we did our first production SDN deployment at SC, which was in 15 or 16. It was very early in the OpenFlow network. It was really early in the controller space, and it was very early in the OpenFlow 1.3 spec that had been implemented by vendors. And we built these things in the lab, and we found really they just kind of worked. Because we had to prototype these things first, right? We didn't want to expend a bunch of resources and then have them fail without having at least tried. So we got them deployed at SC, and we found that the implementation, as we pushed flows into the network, the flows were applied, but it would happily ignore link layer traffic. So anyone that's ever seen a CDP loop or an LDP loop, will chuckle, I think, because it went from no traffic to 10 gigabits per second in about 4 seconds, and it took down the entire SDN network. So we had to work through that. Then once we figured that out, we found a couple of other bugs that were fairly egregious, and we were, I think, about 20 hours or 26 hours or something. It was a very long time straight into it. And we were just about ready to say we're going to revert it to traditional switching when we received beta firmware that fixed the problem. So it came real close to having to pull it out and change it, but it was a harrowing experience that I don't really care to repeat. But I learned a whole lot during that process, so there was definitely a silver lining.
All right. Well, thanks for reliving that. I'll just pause here, and if anybody wants to type in a question or ask a question, please do so. We may not have the most talkative bunch here today. Well, so I think if there's no questions or nobody has anything else they want to bring up, I'll thank Nick again for your time. Send along your slides. I'll make sure that gets posted along with the recording here. And for those that are still on, let me look up and see what next week's talk is supposed to be. Okay, it's Jen Shope from Indiana University, and she's going to be talking about NetSage, which is a monitoring framework. Oh, it looks like Joe typed in a question. Right under the wire, Joe. What scale of the automation have you done so far?
So ESnet's always had a fair amount of what I would consider to be automation under the hood, right? We had the Oscar service, which, has sort of ridden the line between SDN and automation for 10 years. So we have that, very specific task of provisioning a circuit across our backbone. So we've had that, and that's pretty large scale. It touches every element in our network that is a backbone router, which is, we've got an international network, so it's a fairly good size. So that scale is fairly large. We also have had a handful of tools that we've used to do configuration loads all across, a subset or a full set of our systems for quite some time. It would probably fall a little bit more into the category of sysadmin scripting, in my opinion. Right now, we've got a fair amount of templating done. Standard templates that are based out of our source of truth. So ESnet has a back-end system called ESDB that has more or less all the business logic in it. It also has things like, peering addresses and ASNs and IP space, and ties into things like the Merit RADB and stuff. So we have that already. Now, what we've done is we've gone through the process of building templates that are generated out of that database, right? So it's been a learning process, because as we're building these things to use in an automation platform to push configurations out, what we find is that, it's missing, ESDB doesn't have this particular information in it. Do we add it into ESDB, or do we pull it from a different source? So we've spent a fair amount of time figuring out where the data is and where we want to keep it in order to build these back-end templates. But right now, we have the ability to provision basically any external BGP service across any of our peering routers. We've got every router is a peering router basically in ESnet, and we can provision pretty much any BGP service we need to in an automated fashion. It generates the configuration for us based on that model. We also have, which was our pilot, a network lab. And that lab essentially has a bunch of Ansible that says, I have these base configs for the equipment that's in the lab. And let's say we've got 10 routers in the lab and some switches. So we have this Git repository that has all the base configs in it. And I actually have it. I drew the diagram up of this. I have it somewhere. I can share it if you email me and remind me. And it basically is, here's the level set of the equipment. I'm going to branch this in Git. So it requires folks that want to work in the NetLab to learn a little bit of Git, which is really straightforward. It's like 10 commands. It's very easy to learn. And then, they branch their configuration, they make their changes, they do their things, then they commit their changes to this Git repository as whatever they want to call it. And then when they're done, they say, okay, take this back to baseline, and it runs some Ansible that goes out, grabs the baseline configs, pushes it all out to the lab system, and so it's basically defaulted. So that was kind of our hello world of how we're going to start moving forward with automating things, and that started, and then the BGP stuff, templating, started not too long after that, because I think it was pretty clear that that made a lot of sense. So we've got a fair amount of things that are done so far. The BGP stuff is, we picked one of the more difficult things to start with. We also have some automation that lets us build like a new router. If we're going to deploy a new router at a site, we have building off of the Ansible that does the baselines for the NetLab. We said, well, we can build the base config from, it's all going to be very similar. So we can build the base config for any router we're going to deploy, make a few branch out the template, make the changes we need, and then we have a fully deployable router in like 10 minutes. So we've worked through those pieces right now. We're still trying to tie it all together, and we're looking at some other platforms as well to make some of that easier from a workflow perspective. But we've spent a pretty significant amount of time figuring out how to get stuff that we will use every day out in the into production.
All right, great explanation. All right, Joseph, thanks. All right, well, thanks again, Nick. Hope everybody has a good weekend, and we'll talk to everybody next week.
Thanks, everybody.